Hi, this video is all about Python functions. I've realised that I don't know quite as much as I ought to about them, so I thought I would go right back to basics and make a video, and it will be useful for me, and if anyone wants to watch it then that's fine. Right, this is a basic function which takes no arguments and it just prints something. So if we run that, right, just prints no arguments. But all functions actually return a value. So if you put in print like that, it returns none. So the value that my func returns is none. So that is the equivalent of having just a return, or it could be return none. And all functions have that in them, or I'll just run that, have that in them implicitly. Or you could go return 42. Whoops, didn't really want to do that. 42. Like that. And you can have more than one return in your function, but the rule of thumb is if you're returning something from one point in your function, you ought to return something from all points. Like if, for example, you went x equals 2, and if x, no, that isn't that, equals 2, return 42. If you run that, I'll change it to something else because otherwise we can't tell that it did anything. Right, return 45. But if x isn't 2, no, if we're checking this, yeah, if x isn't 2 and you print that, it comes as none. So this is why a lot of people say if you have a return there, you ought to have a return there as well, just to make it look better, so you always know what is happening with your return statements. But that is enough of returns because it's all pretty simple. We'll just get rid of that and we'll get rid of that. Whoops. Now this function that takes no values says prints no arguments. If you pass something to that function, it doesn't like it because it says it doesn't take any arguments and you pass one. So it did not like that. But if you have a function that takes an argument like that, say, and then you can just print like that, there, it takes a equals 12. I mean, sorry, it prints a equals 12. So that is just a simple taking one function. Now, if you don't give it a value, no, it doesn't like that either. So if we have another function that takes two values, like that. There, that works. So these are, if you don't put a equals or b equals there, they are called positional function arguments. And what it does, it takes the first value and it puts it in there, and it takes the second value and puts it in there. But as well as positional arguments, you can have keyword arguments, which is if you have something like that. if I change the value, it would make it look easier to see. Right, there we go. So that's a positional argument. It puts it in A, and then it says, oh, B equals 17, so it puts it in B. But what you can't do is you cannot have a positional argument after a keyword argument. It just does not like that. So if you went like that, I mean, you can, have I done that already? You can do that, yeah. But what you can't do is that. I don't know if you can read that. Positional argument follows keyword argument. No, 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 no. And it's because it really wouldn't know what it was doing. But with positional, no, with keyword arguments, you can actually put them in the wrong order. So there you go. B equals 12, A equals 17. Run that. Yeah, it likes that perfectly well. So all you have to remember is you have positional arguments first and keyword arguments afterwards. As well as that, you can have default arguments. So you can put a default that B equals 100 and run that, and it still comes up, oh, clear that, it still comes up with A equals 17 and B equals 12 because you've put them both in. But if you don't bother to put B in, it uses the default, and you can have a default for A as well. Whoops, that didn't work. You can have default for A, and that's using the defaults. But like you can't have a positional argument after a keyword argument, you cannot have an ordinary argument without a default after one with a default. If you try that, oh, I need to put something in for B. Right, you would think that with that you would say, oh right, I don't need that, therefore I'm taking the 77 and the 23 goes to the B. But then you think, oh, but should the 23 go to A and then I don't have anything for B? It can't make up its mind, so it gives you an error. So if you use default arguments, then they have to be, no, that's the wrong way around. If you have any arguments without defaults, then they have to be before one with the default. Apart from if they're both keyword arguments. So if you had B equals 23, A equals 44, that ought to work. Default argument follows the non-default. No, even with keyword arguments, you have to have the one without a default before the default. So if I just do it like that, that ought to work. Yep, that works fine. And then you can take A out, and that works as well. So that's all you have to remember with default arguments, positional arguments, and keywords. Now you can actually force your program to your function to use something as a positional argument. So as opposed to having a comma b, it doesn't care whether you put in 12 comma 14 or something like that. It does not care. But if you want to force it, I'll get rid of those, that you want those to be positional arguments, if you put in comma, whoops, like that. Now what that / means is all the arguments to the left of it have to be positional. So if you go 12 comma 14 like that, yeah, that works perfectly. But if you try to go b equals 14, no, the function got some positional only arguments passed as keyword arguments. Well, yes, that means you shouldn't do it. And in the same vein, if you put an asterisk in, like asterisk, like that, get rid of that, that asterisk means everything to the right of it has to be a keyword argument. So we'll try running that. Takes 0 positional arguments, but 1 positional argument and 1 keyword argument. Yeah. So you think, I don't really understand that. And you think, well, yeah, with the asterisk, I wanted 2 keyword and no positional. So with that, that ought to work. And equally, because they're keyword arguments, you can go like that, and it still likes it. And of course, you can combine the two. So it's easier to keep them in order. So we've got a comma b, then we've got /. Now that means that a and b have to be positional, and then you go asterisk comma c comma d. Now what that does is expecting 2 arguments that are positional, followed by 2 arguments that are keyword. So if I just copy that, copy, this will show you what I mean. I'm not adding defaults. With all this, you can add the default value. Oops, you can add default values as well, but it is just too difficult. So we'll try comma c equals 55 comma d equals 77. Right, so that is expecting 2 positional arguments and 2 keyword arguments. Oh no, it got some positional only, so oof, no. So you have to look very carefully at that. So you think, right, okay, I'll delete that and I'll delete that. So what you've done here is you're passing in 2 positional and 2 keyword. That ought to work fine. Yep, that does work fine. And you can even, as before, swap that round. Not E. E does not exist. Right, we will try that. Yep, that works perfectly. But to further complicate things, and you'd have to really work this out to work out what on earth is going on, as opposed to passing in 2 positional followed by 2 keyword. In between there, and I'll change that to, it's so much easier if you keep them in the right order. Right, A and B have to be positional, E and F have to be keyword, C and D, it doesn't care. So you can still do this and you go like that, whoops, like that. So you've got A, B, C, D, and then you go E and F. So here, positional, positional, then you can put in 66. Oh, no, I don't want to 666. That is very bad news. Right, so here you can pass in, I do like spaces, that makes life look a lot easier. Right, so you're passing in 2 positional, A 12, B is 14, C is 66, D is 88, and then you got that wrong. You've got E and F. Okay, that ought to work. Yep. So that is 2 positional, 2 don't care that are positional, and then 2 keyword. But you can change that. If you really want to live dangerously, you can go D equals. Yep. So as long as you follow the rule that all your positional have to come before all your keyword, you're okay. And you can even, I think, I haven't tried this, will that work? So that says you want 2 positional, yep. Then I don't care for those, so that's your positional for the first one. Then D is a keyword, but I'm putting it after E and F. Will it cope with that? I don't know, did it cope with that? Yeah, it copes with that perfectly well. But you wouldn't actually, if you were in your right mind, you would want to do that because it's jolly, jolly, jolly confusing. So that just about covers what you can do with forward slash and the asterisk. Now we're back to just a very, very plain function. Now with a function like that, you might not know how many arguments you want to pass in. So there's a clever thing that you can do. You can put in star args like that. And what that does is it says, right, you can pass in any number of positional arguments, because that's what the star means, and it will cope with it. So if I just change that to printing like that, we'll run that. Right, it puts them in a tuple and it says, yep, you've passed in 12, which is great, and you can put in more, and however many you put in, it will put that in star args, that lot in star args, and then it will produce a tuple, which is great. And this star args is a convention that it's a star that means something. The args is just to help people understand what you're doing. Because if you put in something like that, people think, well, what on earth are you doing? Whoops, I should have changed the number. Oh, can't see that it actually worked. Right, run that. It works exactly the same. So you can put in cats, dogs, whatever. But args is better because otherwise people do not understand what you're talking about. And if, say, well, that will cope with not passing any arguments in. You just get an empty tuple. But if you wanted to say, right, I want at least one argument, positional argument, but then I can have 1 or 2 or 3 or 4. If you go something like that, that means it's expecting, whoops, I don't know what happened there. It's expecting A, the first positional argument, and then any number of args. So let me just show what happens there. Right, so there we go. It says my func, I want one positional argument and then any number afterwards. What would that do? No, no, I told you I wanted 1. Right, so there we go. You've passed in 44 to A, and then you haven't passed anything in to args. It copes with that. And if you do it like that, it says A is there, and then your tuple contains 33 and 55. So that is just about what you can do with star args, apart from, just like it gets confused if you try and put keyword positional arguments after keyword arguments. It does not like that, because it says, right, I want any number of those, and then I want 1 on the end. Oh, I don't think that will work. No, it doesn't. Because it's going, right, any number of args, it go doobie 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 do, and then it says, oi, where's my A gone? I mean, you can get round it if you, that is just for positional arguments, so you could call that a keyword argument. So like that. I think that will work. Yeah, there we go. It's taking all the positional arguments from there and shoving it in args, and then a keyword argument, and it's shoving it in there. But that isn't very nice. It's a bit confusing. And there's another thing that you can do. If you put star star quarks, that is doing exactly the same thing. I'll just comment that out, because otherwise I have to keep typing it in. Right, what that does is it says, right, this function takes any number of keyword arguments, including naught, which is why that wouldn't work. Get rid of the positional ones. And then it stores those in a dictionary. So we'll see what that does. There, that is a dictionary that has A is 55. And you can go C equals 99. y equals 655, something like that, and there you have a equals 55, c equals 99, y equals that. Or you needn't have any at all, and then you just have an empty dictionary. But as before, if you want something, at least one quarg, keyword argument, you can go like that, D and your quarks, and then you can pass in D equals 44, E equals 77, F equals 99, and that wants to be print D. And what that does is it says, right, D is 44, so that goes in there when it prints it out. And then the quarks, the keyword arguments that come afterwards, say E equals 77, which is down there, F equals 99. So that's a way of forcing at least one keyword argument, but it has to be D. But as opposed to, I think this works, as opposed to arguments like that, no, I got that wrong, right, leave it as it was. As opposed to, with the args, you have to put A first. It doesn't care. It does not care. You can put the quarks before and the D, which is a quark, afterwards. I hope this will work. Yeah, it doesn't care. Oh yes, there's the 88. Right, it doesn't care which order you put them in. So that's fine. And a final thing, you can actually go star args, star quarks, and here you can go print args, and there it says the star args have to be before the star quarks, because that's what you always have to have positional before keyword. And if you run that, it will say, right, you didn't give me any positional arguments, so I've got an empty tuple. It didn't give me any keyword arguments, so I've got an empty dictionary. And you can go H equals 99. So everything works as it did before. So that's just args and quarks. Now, just a quick word on function aliasing. Now, function aliasing is when you create an alias for a function, which in itself isn't that useful. But what you can do is, depending on what you want to do, you can create a function alias that might be for one function, or it might be for another, if you get my drift. So if you've got a program and you wanted to output something, and you might want to output it on your OLED, or you might want to output it on your Cosmic Unicorn, if you're lucky enough to have a Cosmic Unicorn, then you can just set a flag and decide at the beginning what you want to do. So I'll just show you what I mean. Right here. There's the function for displaying on the OLED, and it just prints that you're going to be displaying whatever you put in there on the OLED. Otherwise, you're displaying it on the Cosmic Unicorn. It isn't actually doing anything, it's just printing out. So, excuse me. So you've got this Boolean was disp OLED equals 2, and you go, if disp OLED display that function, which is a function alias, you make it an alias of that. Or if you want to not display on the OLED, you're on the Cosmic Unicorn, so display is an alias of that. So then when you come down here, display, because disp OLED is true, you're calling that. And if it's false, you're calling that. So I'll just show you what it does. There we go, displaying my output on OLED, which is what you want. And if you put that, false, displaying my output on Cosmic Unicorn. So it's as simple as that. Of course you can make it a lot more complicated, but that example is very simple. Now another thing that I find very useful is a thing called partial. I've used partial in the past. It's especially good for if you've got a callback function, for example on a button, and you've got 3 buttons that are red, green and blue, and you don't really want to have to write a function to say what happens when the green is pressed, what happens when the red is pressed, and what happens as blue is pressed. You want to have one function and you pass the colour to it, otherwise your code gets totally out of control. So it's in functool, so import partial, and this is quite good because apart from for callbacks, if you've got something that you're going to be using the same values in it again and again and again and just changing one of them, if you do a partial function, it will save you a lot of time. So I've just got a simple function like that, and what that does, if you go print power 2, 3, so that you put in your 2 arguments and it raises a to b, so that's 2 cubed. So we'll just run that. 8, yeah, 2 times 2 times 2 is 8. But you could create something called a partial function called square. So you go square equals, you go partial, then you put the name of the function, and then you as I'm squaring it, I want b, because that's what I raise it to, b equals 2, and then I print, whoops, I can't spell, square, I still can't spell square of, what shall I square? Oh, let's square 4. Right, so what that does is it's calling square, and square is power with b2 substituted for b. So you're going, calling that, raising a to the power, which is 4, raising 4 to the power of 2. There, that works excellently. And you could also, of course, create another one that's called cube. So you just raise it to the power of 3, and you're still doing that. So 4 times 4 times 4 times 4, 50. Is that right? No, 4 times 4 times 4, 460. Yes, that's 64, which is quite lucky. My maths is abandoning me. And there are a couple of other things you can print. If you're interested in what's happening, you can go something like print cube, whoops, dot func. Now that ought to give you the function that cube is built on. There, function power. Yep, that works. And as well as that, you can go func args and func keyword. Whoops, keywords. So there we go. Print func. Right. Did I print enough? Right. The shell. 64 is that. Then that is the I missed out one. Fogs. Oh, I missed out args. I jolly well missed out args. That doesn't help. I was wondering why I didn't have enough. Right, args. Right, so this will just to actually see what you're getting at, equals, that ought to do it. Then we'll do another F string. I should have done this before. Equals like that. And then F string like that, and put, whoops, equals, right, that made it a lot clearer. Right, so the function is based on power, and that gives the address of it, and the args, you haven't passed any args into it, because cube, I've just passed in one keyword argument. So there we go. No args, one keyword. And you could actually create another from this power function. You can create another one. So you can say raise to power x equals, and then again you're basing it on partial and power, and this time you are raising to the power of x. No, you want to raise x to power. Yeah, that makes sense. X to power. So you're replacing a, which you can actually, we'll put x there. Right, so raise power to x. So if we just go x equals 4, for example. Now x equals 4, you're creating a function that says raise x to the power of partial of power x, and what that does is it's a positional argument. I'll get rid of that lot. Get rid of that lot. It's making things right. It's a positional argument, so it's putting x in A, and then you can go print whoops, didn't want to do that. Right, copy, paste, raise x to power of oh, we'll go 3, see what that does. Right, so that says you're creating a partial thing, a partial function from power, and it's putting x into A, and then it's going raise x to the power of b equals 3. Will that work? Yeah, that works. So you can create all sorts of things with partial functions, and you can even use inbuilt functions. But the trouble with inbuilt functions is you might not know whether they have keyword input or positional input, or and if it's keyword input you might not know what on earth the keywords are. But I'll just show you another example. I'll get rid of all of that. Right. From math, import pi. Now I'm creating a function like that, and all that does is, if you go whoops, print multiply 2, 3, 4, there. If you multiply 2 by 3 by 4, you can you get 24, and you could go, if you wanted to do this, you can set a variable r equals 5, for example. That's a plus, r equals 5, and then you can go print multiply 2 times pi times r. Now that looks familiar. That looks like the circumference of a circle. Yeah, and that is what it is. It's 2 times 5 times pi, which is 3.1 whatever. So that looks fine. But if you're thinking, right, I don't really want to use multiply for this, I would prefer to have a whatever you call it, a partial function that does it, and all I do is put in the radius and it will return the circumference. So circumference, if I can spell it, equals partial of multiply, no, didn't want multiply, and then it's positional arguments. So the first one is 2 and the second one is pi, and then that ought to do exactly the same, because circumference is taken multiply and put in 2 in A, pi in B, and then it's waiting for C. So if you then go, I might as well copy that, copy, print, whoops, copy, print circumference of R. That ought to do exactly the same thing. I'll get rid of that. So that means that as opposed to always multiplying, you can put it in your little function, your partial function, and that's about all there is to it. Apart from, I'll just show you my code snippets from, I can't remember what video it was. It was when we were doing Qt5, and as I said, you don't want to have to have 3 of those functions, one for red, one for green, one for blue. You want to be able to pass your colour in, and I was trying to pass my colour in down there, and I realised I had to use partial. So what I've done is clicked equals partial, and it's push button clicked, and I've just put colour, which comes from there, 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 and it passes colour into there, and everything works perfectly. I just thought I would show that. If you want to see more, it's on one of my other videos. I'll see if I can remember to leave a link.